All right, we're going to wrap up our discussion of volume and surface area with surface area of pyramids and cones. So the only pyramids we're going to be talking about, though, are regular pyramids, and a regular pyramid is a pyramid whose base is a regular polygon, or in other words, all the sides are the same length. It gets a little more complex when we have bases that are not regular polygons, so we're just going to stick with those. And we're going to introduce a new measurement. So on pyramids and cones, we're going to have something called a slant height, and that's the height of each triangle that is a lateral face, not the height of the pyramid itself. So that's a little bit different measurement, and we need to know the slant height, not the height of the pyramid. How do we find the surface area of a pyramid? Well, if you think of a net of a pyramid that I have here, again, we're going to be sticking with the lateral surface area plus the area of the base, just like we did with our cylinders, just like we did with our prisms. But now we only have one base, so we don't need to double the area of the base. So in short, we just have these triangles plus the area of the single base. So what I did is I took these triangles and I kind of rearranged them, as you can see down here at the bottom, into a parallelogram. So every pyramid, the lateral faces, when laid flat and rearranged, we're actually going to get another parallelogram. So it's just like that rectangle that we got when we unfolded our cylinders, when we unfolded our prisms. When you unfold the pyramid, you're going to get a parallelogram. So we're still using the same concept of that lateral surface area being one long parallelogram, and then we just add the area of this base here. So again, it is lateral area plus the area of the base. Well, how do we get the lateral area? The base of this parallelogram is not going to be the perimeter of the pyramid like it was with the prisms. It's actually going to be half of the perimeter. So half of the perimeter is on the top, and half of the perimeter will end up on the bottom, since we had to rearrange those triangles. And then the height of our parallelogram is going to be that slant height, which is a lowercase l, the slant height. So that leads us to our formula right here of 1/2 of the perimeter times the slant height plus the area of the base. And again, that's reiterated here. We get 1/2 of the perimeter times the slant height plus the area of the base. So let's take a look at an example of a pyramid here. Here we have a pentagonal pyramid. We haven't talked about how to find the area of a pentagon, but they give us the area right here. So be on the lookout for that. We already know big B, so we just have to use the perimeter and the slant height to help us here. So again, I start with my surface area formula, 1/2 of the perimeter times the slant height plus the area of the base. So I already plugged in the area of the base, which was given to us. That was 27.5. The lateral height, or the slant height here, is 15 centimeters. And then the perimeter of my base, well, this is a pentagon that has 4 centimeters on each side, because remember, these are all going to be regular polygons. So every side here is 4 centimeters, and 4 times 5 is 20. And then the 1/2 just comes down here. So I do this calculation. 1/2 times 20 is 10. 10 times 15 is 150. And then I have the 27.5. And then when I combine those together, I get the surface area of my pyramid of 177.5 square centimeters. Easy peasy. Here's another pyramid. Let's start from scratch. We don't know anything, just the measurement of the base and the slant height. So let's calculate our surface area here. So again, we're going to use 1/2 of the perimeter of the base times the slant height plus the area of the base. 1/2 times the perimeter of the base here is going to be 12 times 4, because again, this is going to be a square. It's going to be a regular polygon. 12 times 4 is 48. That's the perimeter. And then my slant height is here. That's 13.4 yards. And then I'm going to add the area of the base. And the area of the base here, this is a 12 by 12 square, and 12 times 12 is 144. So it's 144 square yards is the area of the base. And then if I do this calculation here, I get 321.6 plus 144. So my surface area is going to be a total of 465.6 square yards. And there is the surface area of our pyramids. Cones are a whole nother story, but again, we're going to stick with the same basic template. It's that lateral area plus the area of the base. Well, the lateral area, that's a little bit more complex of a proof of how we get that. So you're just going to have to take my word for it in this video on how we find the lateral surface area. We can have the discussion another time on how this is proved to be what it is. So our lateral surface area is actually going to be pi times the radius times the slant height. That's going to give us the area of this blue space right here. When you unfold a cone, we actually don't get a rectangle this time. We have to get this partial circle looking shape. And then, of course, the area of the base is a circle, so that's just going to be pi r squared. So the lateral surface area plus the area of the base, pi rl plus pi r squared. And again, that's shown here. Our lateral surface area is pi rl plus pi r squared. So let's take a look at this example. We have a cone here, pi times the radius times the slant height. Well, my radius is 7.3 feet, and my lateral height or the slant height is 11.6 feet. So that's where I got these measurements here. And then pi r squared for the area of the circle base is going to be pi times 7.3 squared. And then again, I work through this calculation here, waiting to the very end as always to do my calculation times pi. And the surface area of this cone is going to be approximately 433.4 square feet. So let's give it a shot on this one. What's the surface area of this cone? And that's going to be pi rl plus pi r squared. So the lateral surface area is going to be pi times 4 times 10 plus the area of the base, pi times 4 squared. And pi times 4 times 10 is going to give me 40 pi plus 16 pi. 4 squared is 16. And then again, I'm going to combine those to give me 56 pi. And as always, I wait till the very end to do my calculation with pi. Rounded to the nearest tenth, I get 175.9 square centimeters as the surface area of my cone. And there you have it.